ship on my way to Mars on a collision course. I am a satellite. I'm out of control. I'm alone in the family of the sun. Curiosity tasting everyone on a home. There's some from the sun. Out of the silent planet come the demons of creation.
Still muscly and everything. How's space?
All right. Hello, everyone. We have a bit of a contest today, but also what I hope to be in a learning experience for my students and for anyone else tuning in who want to see an engineer and a scientist battle it out over which Mars missions are most valuable. Not to indicate that any aren't valuable, of course. So quickly around the table, we have our scientist competitor, Tanya of Mars. Tanya, your justification for being here, what makes you a Mars expert?
I've worked on a bunch of missions on your list, so I figure I got to come and represent them.
Fair enough. Okay, so as you might have surmised, the two competitors did receive a rules list, which listed the missions that they're about to draft. I'll go a bit more into that before we start. And up against Tanya today is Dr. Raymond Francis. Raymond, what makes you a Mars expert?
I've worked on only 2 of the missions on the list, but both of them rovers. And in fact, I'm currently working as Chief of Science Operations for the Perseverance Mars rover.
Okay, I'll count that. And judging today, sorry, I'm just setting up a redundant recorder. The engineer, I hope, appreciates this very valuable effort. And judging here today, Dr. Phil Stuke, the originator of this course. For any of you who are watching this as part of my course, any of you who are watching it just for fun or watching past space clubs will know Phil. Phil, what makes you a Mars expert?
Oh, well, I wrote the book. Or a book, anyway. A book about Mars.
Multiple books.
Yeah, and volume number 3 is on the publisher's desk now and not on my desk anymore. So I'm very pleased about that.
I will make a space for it on my shelf.
Oh, very good.
All right. So I decided that we would just flip a coin to see who goes first. But then you have to decide who gets to call. Does anyone have a preference for who gets to call heads or tails?
Ooh. I think you should flip a coin to see who gets to call.
But that's unending.
Is that like a recursive function?
All right, Raymond, you pick. I'm flipping now.
All right, heads.
And I'm not sharing this screen, but tails has come up. So Tanya has first pick. Just before we go into it, I guess I should explain a little bit about what we're doing. The two competitors have to draft, as you hopefully can see on my screen, but if not, I'll edit it in post, as they say in the biz. They have to draft 5 historical Mars missions. And the premise here is that each of them is going to some sort of alternate universe where no knowledge of Mars exists. And they bring with them only the knowledge from the 5 missions they draft. That will somehow include future data collected by those missions. We can ignore that as some sort of Star Trek subplot that doesn't get explained. But yes, so whatever 5 missions they draft, their universe only knows those 5 missions worth of Mars. That's their only knowledge of Mars. And at the end, Phil will judge whose universe or society will have a better understanding of Mars. So yeah, I hope that's clear. They have a budget, and each mission comes with a cost that I'll keep track of here as I've set out. And they have to stay within 100 fictional units. Let's say 100 billion fictional units. Yeah, that's about it. Any questions, last minute questions from the competitors?
I don't think so.
All right. Tanya, you're up.
Okay, I'm gonna start with Mars Global Surveyor.
Oh, okay. Okay. Whoops. There it is. Mars, not Mars Odyssey. Okay. Why Mars Global Surveyor?
So a lot of the foundational information we have about Mars that we use to plan pretty much everything after Mars Global Surveyor came from this mission. It gave us the first high resolution images of the surface that we used to help pick the landing sites for Spirit and Opportunity as a basis, not saying those missions exist, I guess, in this universe yet, but they were high enough resolution to pick landing sites in a way that we weren't able to do with other missions. It also made some pretty big discoveries about things like sedimentary rocks on Mars, which we didn't know were a thing before. We saw new impact craters, we saw new gully flows, we discovered gullies in the first place. So Mars Global Surveyor really revealed how complex of a planet Mars was in a way that we didn't fully grasp from the lower resolution data that in the prime universe we had from the older missions. And it lasted for so long. We got a ton of weather data as well. So it gave us a really good understanding of the cycles of weather on Mars. We knew before that Mars had things like these global dust storms, but we didn't really know the patterns of them and kind of the seasonal variations until we got these, I think at the end of the mission, it was something like 5 or 6 Mars years worth of nearly continuous weather data. So that was really, really beneficial for just understanding the current day dynamics of what Mars is like.
Okay, so you've spent 25, a quarter of your potential budget to get an orbiter. So an orbiter went first, which I was thinking maybe, but I thought also maybe there's some pretty key ground assets. Just a quick check-in. What are you guys seeing on the screen right now?
Looks like the
Mars
Mars
Express.
Express graphic to me.
Okay, I know what I'll do. Raymond, how do you feel about your opponent's first pick?
I think that was a good choice. I think MGS was high on my list too, and for reasons that Tanya has elaborated. But that's what happens when you pick the wrong coin side there.
Wait, was it going to be your first?
No, I don't think so.
Okay. Phil, thoughts on Tanya's strategy for first overall pick?
Well, my thought is that Raymond must be kicking himself that he didn't get to choose that first, because I think that is an absolutely spot on first choice. Tanya mentioned high resolution imaging and long-term climate monitoring, but I would have emphasized the importance of global topography, because that was our first view of high resolution global topography, and also the compositional data, which are not as good as what we're accustomed to now, but they gave a first good look at the distribution of different kinds of surface material, and including, for instance, identifying the hematite that was the goal of the Opportunity rover. So that's a very important foundation mission, I think.
Okay. But notably, Raymond said that wouldn't even have been his first choice. So now I'm very curious.
Oh,
so, Raymond, you're up. Your first choice.
Yeah. So, I think, thinking about, you only get the knowledge that comes from that mission, right? And there's an extent to which every mission builds on the knowledge of previous missions. So what does it mean?
We're kind of ignoring that.
Yeah. So, but the one that I came up with, my first choice, and should I make it now?
Yes.
Okay.
You're up.
Yeah. My first choice was the Mars Reconnaissance Orbiter. An MRO fills a niche kind of like MGS. A long-lived orbiter with a variety of instrumentation. and it has become the reference data set in a lot of ways for missions that came later. You can kind of see it as the replacement for MGS. It's, but it has like a higher resolution camera, and it has a newer spectrometer, and it did the same thing that Tanya was saying: weather data monitoring over long periods, global mosaic images of dust and clouds and things. But MRO also taught us just how dynamic the surface of Mars is, and I think in a way that was not as well appreciated before MRO came, and we could see repeated high resolution views of the surface. And there's things that we came to take for granted with the surface missions later that we actually spotted in MRO images early on. So, between HiRISE and CTX and XRISM and Marcy, it's hard to argue that MRO is not a very rich source of data. And in fact, the data volumes from MRO, just the volume of data in gigabits sent back, were a complete change from everything that came before. So, so that's my argument for Mars Reconnaissance Orbiter as a first choice, especially if MGS isn't available.
Right. Okay. So that's what I thought would go first. When we did this with the moon, pretty sure LRO went first. To me, doing this, I'm just after a global data set immediately, and you two have both done that. Tanya, thoughts on Raymond's response to your first pick?
So it makes a lot of sense. I kind of approach the decision of like MGS versus MRO from a very practical standpoint. And I would say biased by the fact that I worked on MRO in operations.
Mm-hmm.
And a lot of the decisions that we made for things like what were we going to take pictures of in the first place were based on Mars Global Surveyor data. If you look at basically the whole primary mission phase worth of HiRISE image targets, it's all stuff that had been shot at slightly lower resolution with the narrow angle camera on Mars Global Surveyor. The decision to monitor gullies repeatedly with HiRISE and CTX came from observations from Mars Global Surveyor. So I struggled with interpreting, like, should we assume that none of that stuff informed what we did with MRO if we never had MGS and we were just using the data that we were acquiring from MRO? Then I think the mission would have been a little different. So there's very much a bias in like how I was thinking about it from that standpoint.
Mm-hmm.
If we were purely just like taking the data that we have, certainly the data from MRO in terms of spatial and temporal resolution is better than we had with Mars Global Surveyor. At this point, we have like this fantastic weather record. Although I will say we did get global coverage at higher resolution much faster with Mars Global Surveyor than we did with MRO, because we had the wide angle camera that had much bigger footprints on Mars Global Surveyor compared to the context camera CTX on MRO, which took, 13 years, maybe a little more, to get global coverage. So again, we got a better idea of kind of the global dynamics of Mars more quickly, but at lower resolution. So there's like trade-offs on either side. But yeah, MRO is definitely a fantastic choice for having like this rich data set to go off of.
Phil, your thoughts?
Well, it totally makes sense that the first two choices would be these two wonderful orbiters. You have to have that global view. We get it from both, slightly different data sets, but you get it from both. The long-term weather is great. They both do those things. They both did high resolution imaging. So it really makes sense that the first two choices would be these two. And I find it hard to imagine really that you could sort of start off with anything other than those two.
Okay, so as we enter the second round, both contestants have done as expected and snatched up a global data set. Tanya has spent a little bit less money, as she mentioned, in terms of resolution and length of data set as well. MRO is still active. She's got a little bit less, but saved $5. So Tanya, you're up next. Your second pick.
So my second pick in my list originally was MRO. So I got to decide between my two backups there.
Wait, what did you think Raymond was going to do?
I don't know. I kind of thought maybe Raymond would have a rover bias, but I didn't think he would pick a rover first. So I kind of assumed it would come down to MRO versus
Right.
MGS in like the early stages. Okay, I'm gonna go with
Take your
I'm
time.
so
I can
torn
edit
between
it.
these two.
Are they? Well, I think I know which two, but yeah. You know,
Okay.
I'll just say in sports, the younger asset is usually better. So you have a superstar player who's been playing since 2012, or a superstar player who's been playing since only 2020. You might look at that.
If you want to
I
take
mean-
more time, I'm happy to go next. You know,
Oh, sneaky.
No, okay. I'm gonna go for everybody's favorite. I'm gonna go for opportunity.
Oh, okay. Not what I was thinking.
No, the other ones I've got, they're still on my list.
Okay.
So, okay. I feel like of science payoff from landed missions that we've had, opportunity kind of blows a bunch of missions out of the water in terms of like revolutionizing our understanding of Mars from the ground. You know, we got evidence of these shallow groundwater environments. We had detected hematite from orbit, like Phil mentioned, and so kind of completing that story by ground truthing it with the rover. You know, finding within like 20 something sols the source of that hematite, these little blueberry concretions on the ground, which is pretty amazing. And then, as everybody probably knows, you know, this rover just kept driving for almost 15 years, just giving us this really amazing data set on the ground of this environment where we know that there was water in the past. And so really kind of filling in that gap in a way that, you know, we started to tell that story with previous missions, but you know, opportunity really has a legacy behind it for filling in those gaps. And it just holds a special place in my heart for like sentimental reasons.
Raymond, while we still look at some of these images, your thoughts?
I think it's a great choice. I too was going for a rover next, and I think if you're picking rovers, opportunity is a star. It's you know, it from the very beginning, it landed, you know, the famous hole-in-one landing where it like fell in a crater with sedimentary rocks visible from the cameras as soon as they deployed. And then everything else that Tanya mentioned. And the MER rovers, you know, predecessors to the bigger, heavier, more complex rovers that followed, that, you know, the later ones carry maybe more advanced instrumentation that had that was newer, but the Athena science payload on MER was a fantastic suite of instrumentation. And, you know, on Curiosity, we wanted something like Mini-TESS, and Opportunity had it, you know. So they had fantastic instruments. They made a long list of excellent discoveries about the surface and the atmosphere. And from the technical side, we're still building on the foundation laid by the MER mission. The flight software we run on the newer missions draws extensively from what was done on MER, both the initial software and all the software experiments that came later, including a lot of my own work, comes from things that we did on Opportunity. So very much a very successful pioneering 90-day mission.
The longest 90 days in Mars history.
That's right.
Yeah.
Yeah. The team who did Mars time for like 200 sols certainly felt like it was the longest 90 days ever. Yeah, so I think opportunity is a fantastic choice.
Mhm.
All right, fellas, we take a look at the spending so far. Would that have been the first rover you picked, Phil?
It's really hard to say. But one thing I would definitely say in favor of opportunity, I mean, certainly as Tanya mentioned, it basically solved the puzzle of the hematite within a few weeks. That was a great thing. But I thought that one of the most interesting things that came out of that mission was the fact that in its last few years, it was exploring an ancient crater rim, and it did really a lot to uncover the structure, the stratigraphy, the geological history of this crater rim, and it found some clay minerals on Cape York that were a really important goal that they had never even imagined that they would get to at the beginning of the mission. Yeah, so opportunity is a good choice.
All right. Okay, Raymond. So Tanya's on the ground. I have a strong feeling you're going to be on the ground right away as well, probably with a much larger thingamajig. So go ahead and make your second pick. I'm curious actually which way.
Yeah, and I debated about this. I kept trading between there's 3 different rover missions that I thought about as my follow-up to the Global Orbiter. And partly it depends on, something you said in your intro. Okay, so do we get credit for the science that has been done and also the science that it will do? And so on a certain interpretation of that, I'm going to pick Mars 2020.
Its proper name? Or I guess its nickname?
The Mars 2020 mission, which comes with the Perseverance rover and the Ingenuity helicopter.
Yeah. All right. Let's get that up here.
Yeah, and that's a little bit buying a mortgage.
Yeah.
Which we still have to pay off, but this mission has done a lot to elucidate the history of Jezero Crater in particular, just the things it's already done. We know more now than we did. There was a lot of uncertainty about the nature of that place. Jezero being probably the oldest lake on Mars, and there's a lot of context for that. There's more science that it yet will do about the crater rim, so understanding the crater itself and not the lake system that was in it, and about what's outside the crater rim, which includes things that were probably thrown there from the very large, very ancient Isidis impact, hundreds or 1,000 odd kilometers away. So there's a lot of science to be done in situ with Mars 2020, some of which we've already achieved. So if I can take at least mortgaged credit for what's going to happen on this mission, then I think I can claim a lot. And to the extent that I can take credit for what will happen with Mars sample return, with this mission that is, we've collected the samples, we've got them sitting there. Some of we've put 10 of them down on the ground, and we've got a bunch more sitting in the rover, and we will collect more in the next years. To the extent that I can claim any credit for Mars sample return, I think that's a huge boon to my team. So this is, yeah. So depending on how you interpret credit for future discoveries, that's why I put Mars 2020 ahead of the other rovers.
Okay, so you get credit for Mars sample cacheing for sure,
okay.
And which means your society is ready, in theory, to pick up some cached tubes. And yes, I mean this as you mentioned, this mission, it has a high ceiling still, in terms of what it could still get done. Will it go as long as Opportunity did? I mean, everyone hopes so, but it's bigger. It's
Mars sample return, hope so.
Yeah. So, but yeah, I think this is a good wager. Like even if it died tomorrow, knock on wood, you've still got some, you didn't waste your pick, I think, but
yeah, both on the achieved science on the surface and on the banking on sample return.
Yes.
Mhm.
Tanya, quickly, your thoughts?
I think that's relying a lot on the future, but you know, Danny said that's okay, so I guess I'm okay with it.
Well, and Raymond's civilization gets to claim first powered flight on Mars. We didn't see the
True.
image there of Ingenuity, but they get that.
Yeah, I mean, the science
That is
results
pretty
from
cool.
the Ingenuity helicopter are slim, not zero, but slim. But
But the coolness results, that's really what matters.
Ah, yes. Well, that's right.
Phil,
Yeah, I suppose I'd also mention the potential for future flight on Mars now that we've got this first one done. Very promising. Yeah, but Perseverance is a fantastic mission. There's no doubt about it. And even if it did fail very soon, we've already got one cache on the surface that can be picked up. It's a great mission. Very good choice. So much, of course, depends not just on the rover itself, but also on the choice of landing site. And this was an amazing landing site, no doubt about it. But so is Curiosity's landing site. So you know, I think this is probably a very good choice.
so what it did do is put Raymond pretty close to the cap with 3 picks left. So maybe you may have seen then in my scoring or my costing, I did weigh the fact that it's only a 2-year-old mission in terms of being on the ground. So I'm assuming it has years to go and therefore costed it high. Of course, you know, with that comes, it is the newest suite of instruments on the surface of Mars. That should be worth something. You know, Raymond Society now has confirmation of the capability of powered flight on Mars. Tanya's civilization will never know if that's possible. So it did cost Raymond quite a bit, but he's got what I actually think would have been my first 2, although maybe I would have went with a different rover than both of you. Okay, Tanya. So taking a look at your score, you've got 50 units left and 3 picks. So we're going to start getting into some smaller missions, I suspect, some shorter data sets. And I'm curious to see which ones you guys pick, because some of that I think is going to be just personal preference or maybe some interesting strategy. But Tanya, for your 3rd pick, what do you got?
So I'm trying to go for the well-roundedness of the full understanding of Mars here. So my 3rd pick is the Phoenix lander.
Okay.
And I picked Phoenix because if we ignore other missions maybe not being there, Phoenix really confirmed buried ice very close to the surface of Mars in the higher latitudes. And that's been revolutionary for, you know, planning for future human missions, for landing in places where we'd be able to access that ice for astronauts to use to make things like drinking water and rocket fuel to get back home. So that's pretty big. And then also the Canadian connection of the LIDAR instrument on board that discovered things like snow in the atmosphere that never hits the ground, but you know, snows in the air, kind of like Virga here on Earth when you see it, you know, raining off in the distance and that rain never hits the ground. So it's like Canada's big claim to fame on the Martian surface. I feel like that's appropriate here. So even though this mission didn't last for very long, it made some really significant contributions in its brief life on the Martian surface.
And it had a harrowing descent, according to this video. It's the perfect landing. So okay, the first lander off the board. So yeah, I mean, you obviously you don't get any mobility with this. You get a single site. Not a overly long-lived mission, but not an expensive one. I don't know if you have the score sheet there. How much did this one cost you?
10, I believe.
Okay, yeah. So you know, essentially $10 to get a lot of meteorological data, and the first lander. Raymond, thoughts?
that was my next choice. I was absolutely going to pick Phoenix.
Ah.
I think Phoenix. Well, you know, Phoenix was, you know, named because it was a cheap reflight of hardware and design. So yeah, you absolutely get it for a bargain. And I think it really did deliver a lot in what it lasted about 110 sols or so. So yeah, great selection. Sorry to miss it.
All right, Phil, very quickly to you on Phoenix.
Yeah, another very good choice. I was particularly impressed with that mission, that what it found as it dug down and encountered that ice was so close to what was predicted. The predictions were very, very good for that mission.
All right, so I'll update the scoreboard while we turn to Raymond. Raymond, you're going to be making your third pick. You're starting to run up against some cap issues, as we say in the hockey world. So Tanya has picked Phoenix for only, what was that, 10. So Tanya's only at 60. She's still spent less than Raymond. There we go. All right, Raymond.
Okay. Yeah, so Tanya grabbed Phoenix, and I was certainly going to go there next. So now I have to think about how do I piece together my puzzle of Mars science with missions that still remain. And
I'll just point out the Soviet Mars 3 mission is on the board, and it comes with what might be an image.
You're right. That's right. Yeah, and it was cheap.
Yep.
Yeah. And so, well, I think you're right that one of the big discoveries, Tanya is right, that one of the big discoveries was confirming the ground ice there. Sure, for 10 fictional giga units, you can confirm that with the lander. But another way to know about that is if you select an orbiter with the right kind of neutron spectrometer on it. And so I think I'm going to pick Mars Odyssey next, 2001 Mars Odyssey. And this is going to tell us that there's massive amounts of ground ice distributed all around the polar regions at Mars. It's not going to get us a picture of them with a little camera, but it's going to tell us a lot about their distribution and their extent. Unfortunately, Odyssey is very expensive compared to Phoenix. So that's going to put me into a difficult situation. Yeah.
Okay, so two orbiters. First person to double up on any sort of mission type. Tanya has yet to do so. Tanya, were you thinking of Odyssey at any point?
Odyssey was my backup choice for MRO, since my original top two were going to be MGS and then MRO. Because we got a lot of subsurface ice data from the radar instrument Sherrod on MRO. So it felt like slightly redundant to Mars Odyssey, even though the neutron data certainly gave you much more extensive information about the buried ice, in a way where it was like, we're pretty sure this is what the interpretation is. I guess it's the same with the radar. Like, we're pretty sure it's ice, but except in the places where you can see it, like with the ice excavating impacts that we can see with MRO, or the ice we dug up with Phoenix. A lot of it is like, this is our best guess based on the interpretation of the data, because we're not directly observing the ice. But Mars Odyssey, it's what says on the screen right now, longest operating spacecraft at Mars. So it's giving us a ton of information. This is a really solid orbiter to pick. Also very important as a communications relay for all your ground assets.
That's right.
Yeah, we're kind of ignoring comms in the Deep Space Network. You both have a Deep Space Network.
Yeah.
Yes.
Phil, Odyssey?
Well, very good choice again. And I think one of the most significant, I mean, let's say that, you know, we got composition data and we got this ICE data, but one of the most significant data sets, I think, came from the Themis instrument making daytime and nighttime infrared observations, which give you temperature, and then that gives you thermal inertia data, and that tells you about rock populations on the surface. And that's been very important in landing site selection ever since. So I think that's a very good choice.
I would agree, but I'm just looking at the numbers.
Yeah, I think I may have miscounted a little bit there.
So
Is it possible that a
Northern
JPL
Fuel-
engineer has gone over cost on a Mars program?
Hmm. I don't know. I think you might be down. You might be down to choosing Phobos 2
Yeah.
for one of your missions now.
Yeah.
Oh dear. Oh well.
So, yeah, so maybe Phil can help you think of some of the off the board missions that might have the longest data sets. In the meantime, Tanya's got quite a bit of room to work with. She's mobile on the ground, she's in orbit, and she's got a lander. Where are you off to next, Tanya?
You spelled Phoenix wrong, so you might want to fix that for your students.
I always
I
spell
didn't
Phoenix
like to say.
wrong. Well, you please do, please do.
You've written Phoenix.
Phoenix.
Okay, so this is another one where I was a little bit torn on like which to go back to orbit, like which orbiter to pick, because again, I was kind of like aiming for well-roundedness of data sets. But I think I'm gonna be the first to abandon NASA and pick Mars Express.
Yeah, I thought Express would go at some point. Okay, so that puts you at 85. You're in good shape. And yeah, what do you want out of Mars Express?
So Mars Express is another mission that gave us a lot of good foundational data. You know, this was the first ground penetrating radar that we had with the MARSIS instrument. So we were trying to find, you know, deeply buried aquifers of liquid water. Unfortunately, we didn't find any, at least not early on. And this is a mission where we found the first evidence of hydrated minerals all over the surface of Mars. So this really influenced a lot of the target selections for the subsequent hyperspectral imager XRISM on MRO. It got these amazing three-dimensional color views of huge swaths of the planet, like we can see on the screen right now. It took some images of the moons of Mars because it is in this weird eccentric orbit compared to most other satellites that we have there. It also gave us some really nice limb views, so you could look at some of the atmospheric structure. I can't remember if I already said it's the second oldest mission that is still operating at Mars. So again, it gives us a really good time series of data. And it gives us a lot of weather information as well, because it's taking usually these really huge swaths of images, and it has its little webcam feature where it takes these kind of global views from far away as well, which gives us more information about the weather. I feel like this is a mission we don't hear a lot about, at least not in North America, but it's returned a lot of really important information and beautiful imagery that I think we just don't see a lot of.
Yeah, I mean, I'll say as someone who doesn't pay a ton of attention to orbiters, Global Surveyor, Express, and Odyssey at times in my brain get mixed up. MRO I can keep pretty straight because it's a little bit more straightforward in my head. But yeah, I mean, quite often when I talk to you, you'll mention one of those, and I'm like, oh yeah, that one. Raymond, Express.
Yeah, Mars
Nothing you can
Express
afford
is a great choice. I think you know, it's also a first real victory for the European Space Agency to put an orbiter there, and they built sort of the same spacecraft and the same instruments twice more to go look at Venus and at Comet 67P. So clearly a robust design, and certainly continues to do the job very well.
would be nice if you could afford something like that, eh? Phil,
Yeah, I
as
was
we look
doing
at
additions over here after I got caught with a couple of expensive ones early on,
Yeah.
and I got my arithmetic wrong about. I thought I had not spent as much as I had.
yes,
So now
and
I'm just.
you're furiously ripping through Phil's book to find like missions that lasted a year.
Well,
Um,
yeah. So the problem is, according to the rules, I see now actually I only have 5 points left, and I think all other missions come at 5 points. So
Yes.
I think I can only pick one more.
yes, yeah, I think you're gonna be. We can maybe bust it. You can bust to 105, so you can do 2 off the board missions.
Okay. Okay.
I don't even. Well, there's
Okay.
some.
Well, I'll say then that if I've got to be down to 5 points a mission, I have to pick something that's not on your proposed list. Then I'm
Yes.
gonna come to the table. I'm gonna complete my hand of cards here. The next pick is gonna be Mariner 4.
Okay.
Damn it.
Yeah. So all the
That was on my
I don't
list.
even have it. Was it? I guess for $5. Other than Mariner 9, none of the Mariners are on the list. In fact, let's show the list so you can see what they were both working with. So only Mariner 9, because it at least was an orbiter. So Mariner
What do you-
4 has.
Flyby missions, Danny.
Sorry.
I said, what do you have against flyby missions?
Nothing. They're perfectly fine $5 missions. Mariner 4 certainly has some historical weight to it. So Raymond, is that your only choice, or is that your only reason, or what else do you want?
Well, yeah, I mean, until Mariner 4 took photos of the surface of Mars from the proximity of Mars, we had never seen the surface beyond like telescopic images from Earth. And, people looking through telescopes from the Earth at the surface of Mars, at a fuzzy little disk that was like, we don't even talk how many pixels wide it is because they were looking with their own eyes, had drawn vast conclusions from tiny data about the surface of Mars. And they had, to the point where they had drawn canals and they had imagined jungles and rainforests, and there was all kinds of things happening, and then Mariner 4 got there and changed the world. It literally changed that world into our conception of it into a dry crater desert. And suddenly it went from a place where there were like, little green men and Amazon warriors to the moon. And then later we found out actually Mars is not the moon. There's a lot more going on there that is different from the Earth's moon. But the first pictures from Mariner 4 really radically changed our understanding of the surface of Mars. And it only took about a couple dozen frames, but those were very important frames. So for 5 units, that's my pick is Mariner 4.
Look at that. Look at all that data you've got now.
Mm-hmm.
Look at all that black and white. Phil, obviously, if there were temporal value to these data sets, then this one would be much more valuable in terms of what it was worth in its time. And time is kind of reduced to the value of a lot of the Mariner returns. But yeah, Phil, your thoughts on Mariner 4?
Well, Raymond's absolutely right. It changed the world, and it was profoundly important at the time for what it did. It's not fair to judge it by the standards of modern spacecraft and instruments. What always amazes me was the astonishing audacity of people who thought in about 1962 that they could build some kind of machine and stick it on a missile and fire it at Mars, and it would actually get to Mars and function and send data back. It's incredible. that people could have thought that when they were planning that mission in the early 60s. And they did it. And they were giants.
They were all on LSD. This image, this too, Raymond, you get this. If you're seeing what I'm seeing, it's the first color return.
Coming up. Oh, is this? Sorry, it's
Oh,
not coming.
it's not
The
up.
hand colored one.
This is the
Oh yeah, that's hanging just over here. Yeah.
Yeah, so this first color image of Mars, not necessarily from Mars, is
colored
a hand colored
crayons, right? Yeah.
Yeah.
Yes,
That's right.
interpreting each pixel. All right, so let's go to
Tanya seems surprised. I don't know if she got a chance to comment on this.
Yeah, sorry, go ahead, Tanya.
I mean, the speech that Raymond gave was nearly word for word what I was going to say. I thought I had Mariner 4 in my back pocket and no one would think about it. I'd be like, this is the mission that made it so that we went back to Mars at all. And, you know, Mariner 6 and 7 was like, yeah, they got information back, but they kind of missed all of the most important pieces of Mars just by chance of the trajectories they flew by with. So you kind of have this gap between like Mariner 4 revealing this seemingly moon-like surface, and then Mariner 9 suddenly it's like, oh bam, there's giant volcanoes, there's this huge dichotomy boundary, we see these giant outflow channels. Like none of that stuff. We just, like, if you see the trajectory of, I think, Mariner 7, it like cuts just below where all the giant outflow channels start on Mars. And you're like, if it had just been like half a frame up or something, we would have had a completely different view, you know, a few years earlier. So like Mariner 4 and Mariner 9 are kind of like the keystone Mariner missions that fill in these bits of information about what made Mars interesting. So I just saw what you wrote on the board.
Well, when I wrote 4 in Roman numerals, that just logically followed. But yeah, Phil, you said the audacity of people who sent that. Also, the maybe not audacity, but like and I often talk to my students about this, not within their lifetimes and sort of not really in mine, but in yours and within recent history for sure. Reasonable speculation about what Mars was like was way off from what we would ever hear today. Just based on the fact that we did not have any images from the vicinity. Like Raymond said, they were all sketches from people looking through telescopes. So, you know, I think in the original Cosmos series, Sagan talks about like, what color would the sky be? And would there be visible vegetation? Which to today's students may sound like there were serious people like wondering if there'd be visible vegetation on the surface of Mars. And to some extent there were, and everything from the color of the sky to the color of the rocks and all that. So, you know, Raymond's absolutely right. It changed Mars, you know, from flights of fancy to a reality. So yeah, big mission, not a huge data set, but you'll take what you can get at this point. All right, Tanya, your last pick. You've got 15 left, so you've got quite a few options. Where are you going to go?
Well, are we increasing the cost cap to 105 based on
Oh,
Raymond?
so
'Cause that changes my choice.
Ooh.
I guess that would only be fair. I hadn't even realized that. I just thought, yeah, no, you're right. Yes. Raymond has
Okay.
artificially heightened the ceiling.
The Senate has
Okay,
not yet
just-
approved this, but we have to build, the launch date's coming up.
Okay, so adjusting for inflation, then my last choice is going to be Maven.
Okay. I'll get out of here. And what does Maven cost?
20.
Okay, so you've hit the bang on. Maven. Do I have a Maven visual? I do. All right, what's up with Maven?
So going for that well-roundedness aspect, I figured we needed to have a mission in there that was focused on the atmosphere. And MAVEN helped us determine the cause of Mars's atmospheric loss. We've hypothesized for decades that it was because of the lack of magnetic field, and so the solar wind was just stripping away the atmosphere. We were able to observe that happening with the MAVEN mission. MAVEN also found evidence of a little bit of an aurora at Mars, which suggests that there is some small amount of magnetic field still there. We thought the interior was completely dead, but maybe not based on this information. And so we're getting a really good idea of like how the atmosphere of Mars is interacting with the space environment. And then this provided a good data set for future missions as well. Like if any of the future missions that haven't been selected yet did eventually happen, like HOPE, for example. HOPE was designed to kind of bridge the lower atmosphere gap. How is the lower atmosphere interacting with the surface in the upper atmosphere? And then MAVEN is kind of upper atmosphere with space. So it's again another mission that doesn't get a lot of attention because it doesn't really have a surface imaging camera on board, so we don't get these cool high resolution views of stuff on the ground. We do get some global ultraviolet views that show off things like some of the clouds, but it really is a mission entirely focused on the dynamics of the atmosphere. Actually, just over Christmas of last year, there was like a huge solar event that MAVEN was able to detect and see like how the magnetosphere of Mars, or how the atmosphere of Mars actually grew and shrank within the span of a few days in response to that solar activity, which was pretty dramatic.
All right. So yeah, it kind of made me realize the let's say the space weather environment around Mars, something you're going to have a little bit of a heads up on. Not a ton of geophysics, I guess, captured here, although well, no one took insight, but yeah, you've hit on a kind of the upper area of the atmosphere, adding to, like you say, that full picture from the ground all the way out to some things you want to know if you're going to be operating spacecraft at Mars. So that puts you finished up. We'll look over your full roster in just a sec. We have one final pick. Raymond is scrummaging around the bargain bin as we speak, looking through DVDs and other things that are in there, trying to find a mission. Raymond, what do you got? I'm almost positive I don't have a visual for it.
You might. So, all right. So yeah, costs have grown. You can't always have missions at the cadence you expected. Budgets get tight. And so I think I'm going to try and hold myself to the rules. I can't afford 5 units for another Mars mission. So I think that my final pick is going to have to be some creative budget accounting. And so I'm going to pick something much cheaper than a Mars mission, but that can get us data on Mars. And I'm nominating With Pick 2.
Great.
Okay.
So before we go into what that is, I will point out that this is the second time that an engineer has tried to skirt the rules in my draft missions, because I believe Dr. Macross also broke or skirted or found loopholes in my rules. So I'm just learning not to trust engineers. Raymond, explain your pick.
Okay, so With Pick 2 is the Wide Field and Planetary Camera 2. It's the second wide field camera that was built for the Hubble Space Telescope. And the Hubble telescope is not a cheap mission, but With Pick 2 as a replacement camera is a comparatively cheap thing, cheaper than an entire mission to Mars. And so if I have to live on marginal, like whatever I can squeeze out of my leftover budget, maybe that's something I can cram in there. And there have been numerous studies of Mars over the last 30-ish years with the Hubble telescope. And indeed, the closest up picture taken of Mars that was not by a Mars mission was with Pick 2, when the Hubble telescope was in orbit of the Earth, and Earth and Mars, due to orbital precessions and the like, were at their closest approach in the last 60,000 years. So it's the best picture you can get of Mars without going to Mars. So that's why with Pick 2's on my list.
Yeah, here it is. The best picture of Mars without actually going to Mars. Okay, so you've salvaged something here. You've got yourself some nice imagery. You got a nice global view. Tanya, was this on your radar?
It wasn't on my list of things to pick because it didn't go to Mars. So that's applause to you for pulling something out that I didn't even think of as The Martian. I thought for a minute there you were gonna say like Percival Lowell's telescope drawings of the canals, because that's really where all this stuff with Mars got started. Like that's where our fantasies began.
It's true, and you know, if I was going to claim those as part of my knowledge of Mars, I'm not sure it would add much to accuracy, but it would add a great deal to imagination.
Exactly.
Okay, so we've got some final rosters here. Phil,
I just realized something important that I didn't say about Mars Express, that I don't think any of the other missions that either one of us picked did. Mars Express detected methane in the Martian atmosphere.
That's right. And if you want methane, I mean, that's the reason for the Trace Gas Orbiter, which didn't find very much methane.
Yeah.
didn't find a home in this draft.
Yeah, that's right. And the Curiosity rover, which also didn't get picked,
Yes,
but
so
also has
that
made these methane observations.
Yeah, so this is the only methane mission that made the cut. Well, methane detection in a mission that made cut.
just taking a look at the list of unselected here. We have obviously Curiosity, which in hindsight, Raymond, could have saved you $10. You wouldn't have got the caches or the helicopter. So maybe, but you know, you would have been in budget.
Yeah, it's probably true. But you know, as I say, I was buying a mortgage, and in the current market, you know, you sometimes have to trim the budget elsewhere.
Let's see here. So yeah, Zhurong, not selected, active rover. Yeah, TGO, Trace Gas Orbiter. Spirit, not selected. Insight. The Vikings.
Poor Spirit always gets outshone by its sibling.
Yes, its longer living sibling. You know, when the discussion turned to finding ice, I thought maybe there was some leanings, but it didn't happen. Obviously, there's better options for that. Phoenix did get picked, and the Vikings did not. Perhaps a casualty of their age. Mariner 9 not chosen. Pathfinder and Sojourner, I thought Tanya might go with the nostalgia pick, the emotional pick, but she did not. Phil, was there anything?
My debate there was when I had to, if I got 5 billion extra space bucks, or if I didn't get the 5 billion extra space bucks, like Pathfinder or Spirit were like strong contenders for the end there.
Yeah, Spirit, you still get 6 years of ops. Well, as you get 4 years of ops as a moving thing, I believe, and then another 1.5 years as a unplanned lander. Phil, anything on this list that you're kind of surprised didn't go?
Certainly Curiosity would have been, you know, a sort of fairly likely pick, I think. But I don't know. TGO was another interesting mission. It's doing some good things. But I think on the whole, we've got a pretty good selection of missions here on the scoreboard.
All right, I'll pull up the scoreboard. Could you have made a case for one of the Vikings? Or do you think they're just a little bit too dated compared to what came out?
They were pretty special missions in themselves as well, and you know, a little bit like Mariner 4. Incredible achievements, absolutely incredible achievements for the time, and can't really just compare them with modern landers. You know, just because it's a different time. They could have been there. But I think in terms of the total amount that we've learned about Mars, that the first few missions on each of these lists are really the key missions.
Yeah. Okay, so
I'll say I was thinking about Viking 2 just for that picture of frost on the rocks.
Yeah.
And I was leaning toward Viking 2 for that one, but then I was like, oh, but Viking 1 is like more cost effective because both the orbiter and the lander lasted longer. But I'm not sure that it gave more useful information than Viking 2.
Okay, so we'll run down the roster. So Team Raymond has MRO for its big sentinel in the sky, so to speak. It's got Perseverance on the ground as its main and only ground asset. It's got Odyssey as a backup for MRO and a complementary data set from orbit. It's got a flyby from Mariner 4, providing some historically important images, as well as a little bit of bonus data to fill in. And then it's got some establishing shots, let's say, of Mars from a distance by Hubble, which are very nice and will make for great calendars. And over time, we'll give you a view of changes on the planetary scale. So that's Raymond clocking in at the new limit of 105, as determined by Raymond's own math. And Team Tanya, she's got her eye in the sky, Mars Global Surveyor. Opportunity has her main ground asset, her only mobile ground asset. She's got Phoenix, taking the weather on Mars as her second ground asset. And then she's got two other orbital assets in Mars Express and Maven, both rounding out her kind of overall view of Mars, its atmosphere, its space environment, its surface, and everything else. So, Phil, I know you're just way too nice to call either Tanya or Raymond a loser, but after you make your verdict, I will also weigh in. Not that mine carries the same weight. So, Phil, what did you think about how they both did, and which society do you think is better off in terms of understanding?
Oh dear, it's completely unfair to ask me to choose between these two lists, but since I have to, okay, let's look at Team Raymond here first. We've got really the first three fantastic missions that provide a really wonderful foundation for any kind of future study of the planet. Unfortunately, then he sort of shrivels up, and he had to choose what he had to choose there, just because of the numbers. But the first three are wonderful. Now with Team Tanya, I think we've got essentially the same sort of set of very good stuff in those first two missions, but then I think she makes stronger picks as she goes through. So I think her strategy in spreading out the marks and giving us 5 very good missions, I think that puts her just that tiny little bit above Raymond, even though he made brilliant choices. I'm going to choose Tanya as the winner.
Okay. So I should have said, I should have given you guys both the opportunity for closing arguments. Raymond, do you want a rebuttal, a last minute on the stand to the judge to try to lower your sentence? Defend yourself.
No, I think, well, so first of all, I think Phil is right. I think that, Tanya has an excellent roster of missions. And indeed, I think one of the things you saw is that Tanya and I often chose similar missions, or even the same mission as our first and second and so on pick. I think my list would look very different had Tanya not grabbed Phoenix before me. Because I would have taken Phoenix. And then the numbers and the selection of missions would have been very different after that because of what Phoenix gives you. So Yeah, but it's good. You know, I feel confident in the future of Mars science in my little universe with only MRO and Perseverance and all of its potential future gains, and then the others on the list. I feel like we are well set up to do Mars science in my world.
Raymond, I think we can all agree that the future of Mars exploration is safe in your hands.
I would like to hope so.
Yes.
Well,
Yeah.
I think
Yours.
that. Oh, go ahead.
No, go ahead, Tanya.
I was gonna say the yeah, I mean, there was so much here in terms of like the luck of the draw to start out with. Although Perseverance honestly was not on my list at all. And Odyssey I had as like my backup after MGS and MRO. So we wouldn't have had complete overlap, but it's interesting that like the top like MRO versus MGS and then Phoenix kind of like swayed things there.
Yeah, and yeah, both universes are of course getting yourselves as well. So Raymond's universe is going to have a leg up on rover operations, and Tanya's universe is going to have some image interpretation and science expertise. So that's a bonus for them as well. We don't take that into account on this. In terms of who I would call a loser, I don't get many opportunities to call Raymond a loser, but but unfortunately, yes. I think not having first pick, and then also, there was no reason you would pick Phoenix second, which means that you're not going to get that key mission at a low price, really at all, if you don't get first pick, because it's really going to slot in around 3 no matter what. Although strategically, maybe if you guys both noted that it was a discount, I didn't do that on purpose. I think you both just know more about the mission than I do, and you caught it as a discount, and maybe a strategic pick would have been that one earlier. But that's you learn as you go. Maybe one day we'll do this again with maybe the solar system writ large or something like that. And we'll see if Raymond can retake the throne. But yeah, Phil, I hope you had fun. Did you learn anything?
No.
Phil already knows everything there is to know about the solar system. We can't.
No, it was a lot of fun. It was a lot of fun, and I really enjoyed it.
Yeah. All right. Well, any parting words, Tanya, as champion?
Thank you, Phil and Danny, for letting me keep my crown as professional Martian. I would have been quite embarrassed for my people if I had lost to an engineer. But if I was going to lose to an engineer, there's no more worthy person to lose to than Dr. Raymond Francis. So thank you for a good game, sir, and keep our rovers that are on Mars right now running smoothly.
And Raymond, your parting words?
Oh, I'll do my best to keep things running smoothly over here. I think, this is fun. And, Tanya knows a great deal about Mars science and about the value of these missions. So a very challenging opponent to go up against. And I think, no hard feelings. In fact, I would propose that the true way to approach this kind of exploration in the future is through collaboration and joint missions. And I think we can be more than the sum of our parts.
I agree.
Absolutely.
I agree. Yes, the true path forward is collaboration. Phil, did you want to have anything else last to say?
Oh, I don't think I have anything else I can add to that. Actually, no. But it's been a lot of fun, and I'm glad we all of us who met at Western have a chance to get back together again like this.
Let me know when Atlas Volume 3 is ready.
It'll be about a year.
Okay. Well, that's quick by Mars mission standards.
Yeah. Although I started designing it about 10 years ago.
Oh, then they were right on track.
Were you in budget, Phil?
Yes, I was.
No, see. Well done. That is what we all learned today, I think. It's important to stay in budget. Okay, we'll do this again in some way, shape, or form. Thank you very much, Raymond and Francis. As Raymond said, there's no real loser. Both of these people, all three who joined today, are unparalleled experts, of course. And I'm eternally grateful for that. And as any students watching this should be, to get an opportunity to hear some real experts talk about some real missions. So I hope you enjoyed this. I hope you had fun, and we'll see you next time.
Okay, bye-bye.
Bye.